All right, so again, I remind you that there is a formative tomorrow. It will be on 4-7. It'll focus in on 4-7. So it will be on 10 questions, some composition, some just working with inverses, some on the unit circle, some off the unit circle type things. So that is tomorrow's plan. Then we are also looking ahead to next week. A week from today, we will be taking the test on 4-5 and 4-7. That will encompass graphing, tangents, cotangents, secants, cosecants, using inverse trig functions, and composition of inverse trig functions. So lots of stuff on that test for us next week, Thursday. So with that being said, I think it's only the 3. 'Tis only the 3. Work with me or warm up with those 3 inverse trig problems. All right. So tangent. Where am I looking? Which side of the circle, of the unit circle, am I looking for tangent? Left, right, top, bottom. Right half of the unit circle for tangent? Okay, all right. So where on the right half of the unit circle is the tangent negative square root of 3? We know for sure it's not here, because there's no square root of 3 there. So you're saying this one down here? Okay? Because we would have negative square root 3 over 2 divided by 1/2, which means that would really be times 2 over 1, which those cancel out, gives me negative square root of 3. I would go there, and so I would say, I agree, negative pi over 3. We want to say 5 pi over 3, because that's what we're dealing with down there. But 5 pi over 3 doesn't fall on that negative pi over 2, positive pi over 2 range of values. Inverse cosine being negative 1. Where am I looking for inverse cosine? Left, right, top, bottom. Top half, okay? Where on the top is cosine negative 1? Pi? Arc sine, where am I looking? Right half? Right half. Where on the right half is sine negative 1/2? Negative pi over 6. We want to say 11 pi over 6, but it's negative pi over 6. Okay? Good times. Yeah. Ooh, a little composition action going on here now, okay? So remember, we start on the inside, and then we work our way to the outside. So this is saying here, where is cosine square root of 3 over 2? Where is that? Pi over 6. Okay. So this would then be the cosine of pi over 6, which is root 3 over 2, correct? Now, because it's cosine, we could have also just canceled out the inverse cosine or the arc cosine and the cosines, because those are inverse functions, and we're in quadrant 1. with sines and tangents, we have to be cognizant of the fact that if we're in quadrant 4, then we have to have negative angle values. Okay? Sine of inverse sine of root 2 over 2. Well, this one is pi over 4, correct? So then this would be the sine of pi over 4, which would be root 2 over 2. Let's jump off the circle a little bit. We did a little bit of this yesterday, where we were off of the unit circle. Okay. So arc sine, that's negative. Which quadrant am I in with arc sine being negative? Quadrant 4, right? Okay. So let's draw a quadrant 4 triangle. So this arc sine aspect right here, that's going to give me an angle. Inverse trig functions find angles. So that one's going to find me an angle. Well, I know arc sine is opposite over hypotenuse because sine is opposite over hypotenuse. Our old pal SOHCAHTOA. We can find the other side, the missing side, by doing what? Pythagorean theorem, or if it's lucky enough to be a Pythagorean triple, which 13 and 5 make up 2/3 of a Pythagorean triple, which would be 12. If you didn't know that, we could always go do that. So now we need the secant of our theta. Well, the secant of our theta is going to be secant paired up with cosine. Cosine is adjacent over hypotenuse, so secant would be hypotenuse over adjacent. So this would be 13/12. I'll pause for questions, let that sink in. Everybody good with that? The cosine of the arctangent of -7/8. You guys want to try this one, or you want me to do it? You do it? All right, go for it. Tangent's negative in quadrant 4, right? Because we're looking right half of the unit circle. Tangent is opposite over adjacent. So this would be -7. That would be 8. The Pythagorean theorem would say 8 squared plus -7 squared is c squared. 64 plus 49 is c squared. 104, 113. So this is going to give me my angle theta. Really, it's going to give me my angle theta prime, which would be there, but same difference. It's going to give me an angle no matter what. So then the cosine of my reference angle would be 8 over the square root of 113, or okay. Good. Good time. For some reason I didn't. We can also go algebraic with our triangles and our trig functions and our composite or compositions, not composites, compositions. So this again is going to give me an angle. Okay? Can't really determine, well, actually, no, I lied. We can determine that this is in quadrant number 1 because it's positive. Cosine would be negative in quadrant number 2. So remember, cosine is adjacent over hypotenuse. So I'm going to say that the adjacent side is 3x and the hypotenuse is 1. And I can do that because I could write this in fraction form. If I do that, there's my theta, I have to run the Pythagorean theorem. 3x quantity squared plus y squared equals 1 squared. 3x quantity squared is 9x squared plus y squared equals 1. And I want to solve for y. What will we do next? Algebraically, what will we do next to solve for y? Subtract 9x squared. Algebraically, what will we do next? Square root both sides. Okay. Now, normally, we would have to put the plus or minus on there, correct? Okay. But because we're in quadrant number 1, and we know that we're in quadrant number 1, it's just the positive. Because the y value here in quadrant number 1 is positive. If we were in quadrant number 4, then it would have to be negative of that square root. Understand what I'm saying there? Okay. All right. So we're looking here for the sine of theta, and that is going to be the opposite side over the hypotenuse, or because we're dividing by 1, we could just say that. Questions on that? Okay. With that being said, what I would like you to do is I would like you to find me the cosine of the arc sine of 2x.